Okay, let's talk Pythagorean theorem. Pythagorean theorem is actually pretty neat, and it actually starts about having this first classification about the type of triangle. So if a triangle is a right triangle, then we're going to find a pattern within its sides. So it's important that we know specific things about a right triangle. So a right triangle obviously is a triangle that has one right angle in it. It can only have one. And identifying from that the different lengths with it. Across from the right angle, so once you know where the right angle is, directly across from it is a side that is known as the hypotenuse. Funny name, important side. And the hypotenuse is always going to be across from that right angle, and it's always going to be the longest side in a right triangle. The other two sides of the right triangle are just simply known as the legs. And so, and those are what forms that right angle. And so what we have found is this formula. The area of the square that is built off of each leg added together would equal to the area of the square that's built off the hypotenuse leg. So if you actually take a minute and you look at the Lego right triangle that I made here, I have a right triangle here built with a side length of 3. And so that means its square, when I built the square of it, had 9 pegs on it. And then I have another right triangle, or another leg down here with a side length of 4, which means when I built the square around it, it gave me 16. And then to complete this out here, I built another length here to connect it all around. And whenever I was done, it had a length of 5 along that hypotenuse. And so 5 for one side squared would give me 25. And 9 plus the 16 does give me that 25. So it gives us this formula that's actually about relating the squares that are built off the sides. So we can think of this geometrically as it being about the squares, and we can think about it as a formula mathematically. We're going to look at it geometrically with the squares first, and then more with the formula in the next video. Okay, if we look at the first example, you can see that there's the right angle, and so this side C is the side that's the hypotenuse. That's the side that we don't know. So if I look at the squares that I've built off of my 2 legs, this first leg has a side length of 10, which means this guy is also 10. So its side length is 10, its area is going to be 100 here. Then this next side has a length of 15, which this guy also means it's 15. So that means its area is 225. These two areas together, added up, have to equal this area. So that means that big square is 325. And then I need to work backwards to figure out what is the side length there. So what number times itself gives me 325? That one's not on my list of perfect squares. So I go to my calculator and I use the square root button. And if you don't know where that button is, check with me, please. And I do the square root of 325 and I get that it's roughly 18.03. This hypotenuse should always be the longest side, and 18.03 is the longest side between 10 and 15. Let's try another one. Let's take a minute and see what we're given in this picture. In this picture, I actually have 2 numbers I'm missing, okay? And I have that one of the side lengths there is 6, which means that its square would be an area of 36. And I have an answer here for this guy, that this guy is already 64. So that means its side length, what times itself would give me 64, and it's 8. So that means its side length is 8. So that 36 plus 64 is going to give me a new number here to being 100 here. Okay, that area is going to be 100. That was easy to do. And then I have to work backwards to say, well, what times itself is going to give me 100? And that's one is on my perfect square list. And that answer then would be 10. So there we go. Again, my hypotenuse is across from that right angle. It is my largest side, and it is 10 in this case. Let's look at the next example. Okay, now in this next example, we have something presented to us that's a little bit different. Because in this case, I actually know what the hypotenuse is. I know that that big triangle there is, or that big length there is 25. So that also means this side is 25. So I already know the area of the square is going to be 625. I know that last one there is going to be 625. So what I don't know is what this B side is going to be. So let's fill in what we know so far. So this side length is 7, this side length is also 7, so that means that guy's going to be 49. And so I need to figure out 49 plus what gives me that 625. So if I go through and do my math and then just do basically, 625 minus 49, I get that would be 576. And again, I don't know that one. That one's not on my perfect square list because I need to know. I know that the area of this guy is 576, so I need to know what side length that's going to be. So I need to go to my calculator and type into my calculator square root of 576, and lo and behold, it's actually a perfect square. I didn't know this one. That one's not my perfect square list because it's so big, but that's a side length then of 24. And if I stop and I think about it, my hypotenuse is still my largest side there, 25, because 24 is smaller than 25, but now I have that missing side length. Let's go through and see some examples of just using the formula without the squares built onto the sides.